Hello students, welcome in chapter 9, sequence and series. Students, today I am going ahead in your GP series, geometric progressions related terms and sum, and some kind of our infinite series also. So students, I continue exercise 9.3 first one, question number 17. If 4th, 10th and 16th terms are in GP are respectively XYZ, and prove that XYZ are in GP. Very easy. Given terms are in GP, so terms of 4, terms of 10 and terms of 16. AR is to 4 minus 1. Same. AR is to 10 minus 1. And same. AR is to 16 minus 1. And that respectively given X, Y, Z. Students, here you taking statement 1, 2 and 3. Now what we prove? Prove that X, Y, Z are in GP. It means we prove that X, Y, Z are in GP. So we show that, what we show? Ratio are same. Y by X is equal to Z by Y. Y square is equal to XZ. This equation anyhow I will prove. Then we can say X, Y, Z are in GP. So I start Y square. It means statement number 2 square. So from 2. What is the Y? AR is to 9, making square to both side. It get Y square, A square, but R is to 9 to the 18. So can I write down A into A and here R into R, but I want to XZ. What is your X? AR cube. So here 3, but here 15. They convert to 18. So Y square is equal to AR cube. AR is to 15. Now students, that is your equation 1. That is your equation 3. So I just show it. It is X, it is Z. And mention from equation number 1 and 3. And here students, our proofing is finally done. That's why I am saying X, Y, Z are in GP. And here students, very easily our first question is done. Now students, continue going ahead. Question number 18. Find the sum of first n terms to related terms given 8, 88, 888, 8888. Very easy sum students. We are going ahead in the ascent form. 8 plus 88 plus 888 plus 88 up to nth term. So you have to first of all 8 common taking students. 1, 11, only there remaining are up to n terms. Now what to do? We convert in the GP series. That's why 9 multiply and 9 divided. That is the 9 multiplications, and already students I divided 9 plus nth term as it is. Now I convert into GP. Students, this 8 by 9 same. Here 10 minus 1, 10 square minus 1, 10 cube minus 1 till last they convert nth terms. Now wait, 10, 10 square, 10 cube all are in GP. If you combine 10, 10 square, 10 cube up to nth terms, and minus 1, minus 1, minus 1. You common take minus. It is nth term. Now finally students done. That is your n, and this is your GP. So I just declare in GP Sn become A r is to n minus 1 by r minus 1, because your A is 10, r is 10 more than 1. That's why I operate that data. It means our Sn is running 8 by 9, A become 10, 10 raised to n by 10 minus 1, and here students only and only n. So I easily obtain the value. It is 10 by 9, 10 raised to minus n. Now this 8 by 9 is to multiply inside to both. So you are getting your answer 8 by 9 with the dead. So 90 by 80 by 9 9 is 81, and 10 raised to n minus 1 minus 8n by 9, and that's your students easily. This question is done here students. Now students continue question number 19. This is also very unique sum. Find the sum of the product of corresponding terms of the given sequence 248, 1632 and 128, 32, 8, 2 and half. Students, here telling corresponding terms. It means 2 to 128 you take, 8 to 32 taking. Here 8 to 8, 16 to 2 and 32 to half. Students, by mistake you are telling 4 to you are taking your 32. Corresponding products and that sum. So students, our solution is very easy. Required sum Sn, 2 with corresponding 128, 4 plus corresponding 32, 8 to corresponding 8, 16 to 2 and 32 to half. Just one more time check. 2 to 128, 4 to 32, 8 to 8, 16 to 2 and 32 to half. So students, you have to know 128 is a 2 raised to 7, 64 double. Here 2 square and here 2 raised to 5. Similarly 2 cube same as 2 raised to 4, 2 raised to 1, and that is cancel 16. So students, here 2, 16, remaining here 2, it is 2 raised to 7. Same 2 square, 2 raised to 5. Same 2 cube. Continue 2 raised to 4 with 2, and it is 2 raised to 4. Finally you getting students 2 raised to 8, 2 raised to 7, 2 raised to 6, 2 raised to 5, 2 raised to 4. Now you common taking maximum 2 raised to 4. Remaining are here 2 raised to 4, 2 raised to 3, 2 raised to 2, 2 raised to 1 and here 1. Finally you getting students here 16, 8, 4, 2 and 1. If I rearrange 1, 2, 4, 8, 16. So that is your GP. Yes, in GP, what's your A? 1. Ratio 2 by 1, which is more than 1. And Sn cover A, r raised to n minus 1, r minus 1. So your value applies students here 16. A become 1 and r become 2. Raised to how much? 1, 2, 3, 4, 5 terms by 2 minus 1. So 16 into 32 minus 1, 16 into 31, and they apply to 31 into 16, 0, 1, 3, 6, 9. So here 6 1s are 6 and 6 3s are 18. So 694. Finally 496. Your SN covered here, students. Our question is done. Now students, after that we going ahead our new topic, because in your textbook students now 22 all 32 questions is a cancel there in our syllabus wise. So I not explain, I go to now new topic. Yes, that is a some special series summations, summation of our some special series. That is very interesting question students, and very interesting topic also. So there are generally four formula. First, Sn 1 plus 1 plus 1 plus up to n times you can saying sigma 1 are running 1 to n, and that is n. 1 1 1 adding. Second, Sn 1 plus 2 plus 3 plus all natural number summation, that is called sigma r running 1 to n. It is n plus 1 by 2. Now third also formula very easy. Sum of the square, 1 square, 2 square, 3 square till up to n square, which is sigma r square, r running 1 to n. n plus 1 to n plus 1 by 6. Students, this last term n I written r, last term n square I written r square. Yes, always you write the value related to your last term. Fourth, 1 square, 2 square, now 1 cube, 2 cube, 3 cube, n cube, which is sigma r cube. So n square, n plus 1 whole square by 4. Students, that is your 4 properties, and that 4 properties related I start our new exercise students. Yes, this is the main terms for some special series. Now students, I continue our exercise 9.4. Here also in 9.4 some questions are cancelled, so that not I explain according to our syllabus. First one, Sn I want 1 into 2, 2 into 3, 3 into 4, 4 into 5 plus dash 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 dash. Students, here two terms pairing given. Always you find out the last term of given Sn. So this is the last term I define. So you just focus here first value, first value, first value to each one. So find out last term of 1 comma 2 comma 3 comma 4 dash dash dash, which is Tn a plus n minus 1d. D is 1, that's the n. One more. Now you focus on 2, 3, 4, 5. So last term of students 2, 3, 4, 2, this 3, this 4, this 5. So what is your Tn again? A plus, because it is an arithmetic terms, AP 2, D is 1, become n plus 1. It means your Sn is ready students. 1 into 2, 2 into 3, 3 into 4, 4 into 5 plus here last term is n into n plus 1. So according to this property I show now your summation sigma r running 1 to n. Look at that students, here n plus 1. So I write down r plus 1, this coming from here and that coming from here always. That's why I find out last term. Now very easy solution. Sigma r running 1 to n r square r. Sigma r square sigma r running 1 to n. And now simplify. Very easy. And quickly students, your data down. Sigma r square is this. This is a fixed formula. n plus 1 to n plus 1 by 6. And sigma r students here n plus 1 by 2. Now you common taking. Maximum common. n plus 1 by 2 common. Remaining are 2n plus 1 by 3. And here 1. So finally you can done 2n plus 1 plus 3. So what you getting? n plus 1 2n plus 4 by here 2 into 3. Students, here 2 common taking and easily cancel. So n plus 1 2 common, n plus 2 by 2 into 3. This cancel. So n plus 1 n plus 2 by 3. Here students, our this question is easily done. Now students, continue. I going ahead. Same as second question. That also same is, but second sum students, yes, it is cancel. I going to third one. Question third. Sn become 3 into 1 square, 5 into 2 square, 7 into 3 square plus dash 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 dash. Here also students, you can try to this first term. So last term of 3, 5, 7 continue. Tn define a plus n minus 1d. D is 2. 5 minus 3 difference. So you 3 plus 2n minus 2. So you getting 2n plus 1. Now students, I take here 1 square, 2 square, 3 square alternately. Last term of 1, 2, 3. I don't write down square. After that I last write down square. So Tn a plus n minus 1d. D is a 2 minus 1. 1. It is n. Finally, you can create easily your last term of that and last term of second. So now I create students my Sn value. That's very easy. Our Sn is a 3 into 1 square, 5 into 2 square, 7 into 3 square plus here this last term is ready 2n plus 1 into n square. Now according to last term we can show students sigma r running 1 to n. That's a 2r plus 1 into r square. This 2r plus 1 coming from here and that is coming from here according to your this last term. This n, but I taking to square, that's why written n square. Now very easily you can create 2 r square and r cube plus r square. So that answer is students 2 sigma r cube plus sigma r square, r running 1 to n. Now easy. So 2 n square n plus 1 whole square by 4. Here n plus 1 to n plus 1 by 6. And now you take the common. 2 2s are cancel. Remaining are n plus 1 by 2 common. Remaining you have to n plus 1 by 1. And here students 2n plus 1 n plus 1 by 2 common taking, so remaining only 3. So n plus 1 by 2, here 3n square plus 3n, 2n plus 1 by 3. So your answer is finally n plus 1 by 2, here 3n square, 5n by 3. So you get this answer now, 3n square, 5n plus 1 by 6. And that the students easily our question third also done. Now I continue ahead. Question number third after. Yes students, fourth one. Fourth is IMP for board level, exam level. Most IMP. SN is a 1 by 1 into 2, 2 into 3, 3 into 4 till last dash. Here also students I derive my last term. Just to check here, 1, 2, 3. Convert in last term. Last term of 1, 2, 3. So your Tn define. That you necessary doing, students. Difference is 1. That take only n. Now second number taking. Last term of 2, 3, 4. So what is the Tn? A plus n minus 1d. Value apply. A is 2, d is 1, which is n plus 1. And now these whole values, students, I can show in your SN terms. So what's your SN? Yes, it's very easy to going that 1 by 1 into 2, 2 into 3, 3 into 4 plus here students and with the n plus 1. These both last terms I respectively attach in your SN last term. Now according to last term students, you can say sigma r running 1 to n, that is 1 by r plus 1. This related. Always you can try to according to last term related your SL define summation. Now this is a main step. Students, after that r plus 1 I want to converting into least to least terms. So can I write down r plus 1 minus r? That is same, because r and r cancel, you have to only 1 left. Now this I divided, another that I divided, both separations. So what you get remaining? Remaining is 1 by r, other 1 by r plus 1. Now I start respectively putting value of r. Students, r equal to 1 apply here. So it is 1 by 1. If you here putting, then 1 by 2. Now 2 putting, then 1 by 2, that is 3. Now 3 putting, so 1 by 3, 1 by 4. Similarly, if I put it 4, then 1 by 5 here, plus dash. At the last put it n. So what you get? 1 by n, but here n plus 1. Students, you check this second with first cancel, second with first cancel, second with first cancel. So second with first cancel, again this one of the second with this first cancel, remaining you have to 1 minus 1 by n plus 1. Now answer n plus 1 minus 1 by n plus 1. Your data n upon n plus 1. And here students, this IMP questions 4 easily done. Now I continue going our fifth sum. Fifth also IMP, exam related. Find the sum of 5 square to 20 square. Question number 5, tick in IMP list. SN want 5 square, 6 square, 7 square, but in 20 square. One more time check, 5 square to 20 square. Students, this is a limited terms, but I want to anyhow last term, not this is the last term, I want to last term of 5, 6, 7. Don't take this is the last term. So what's your Tn? A plus n minus 1d. Difference become 1. It is n plus 4. So your Sn is ready students in this way. 5 square plus 6 square plus 7 square plus 20 square plus this n plus 4 square. This is the last term. No doubt I want to only these summations, but necessary you can show your last term necessary. So students, here you can create Sn sigma r plus 4 square according to this last term. R running 1 to 16 because n plus 4 is become, you write down 20, this n becomes 16 and that n converted in the r. So 1 to 16 term you have to only. Now very easy, you can create easily your way to whole square and easily answer also students. So that is Sn now coming. Sigma r running 1 to 16 and that the students whole square taking r plus 4 whole square, r square, 4 to the 8r and 4 square is a 16. So sigma r square, 8 sigma r, 16 sigma 1, r running 1 to 16. Now students, look at that. Sigma r square means this formula. R put it only here 16. So 16 plus 1, 2 times 16 plus 1 by 6. Continue. Sigma r, it means this property utilizations. Sum of the 16 terms, but r put it 16. So here 16 plus 1 by 2, and that is utilization 2, our first one, n. So here 1 to 16, it is 16. Here 2 8s. So finally you can done 16 with the 17 with the, here 32 plus 1, 33 by 2 into 3. So 2 8s are 16, 3 11s. Remaining are here students, 8 8s are 64 and another is a 17 plus 16, how much? Yes, 256. Students, it's very easy. If you converted a 17 common here, 11 8s are 88 into 17 plus 64 into 17 and here 256. So can I calculate this too easily? 17 common, remaining 88 plus 64, 256 same. So that become 8 and 4 12, 1 carry, and 8 and 16 14, 14 and 1 15, 152, 256. So 152 into 17, 2 1s are 2, 5 1s are 5, 1 1s are 1, 7 2s are 14, 1 carry, 7 5s are 35 plus 1 36, 3 carry, 7 1s are 7 and 3 10. So 4 8 5 2, it become 2 5 8 4 plus 256. So here 10 1, 8 and 5 6 13 and 1 14, 1 5 6 7 and 8, 2 8 4 0. And here students, your 5 square to 20 square done. but I again repeat, anyhow you can create last term and after that focus to 20, then n plus 4 20 are 16 and 16 term I dissolve here students. Now students, going ahead, one more questions, our sixth one, same pattern, asking to summation of given n terms. So data is a 3 into 8, question 6, 3 into 8, 6 into 11, 9 into 14, plus dash 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 dash. So students, here also I want to last term 3, 6, 9. So first of all I derive last term of 3, 6, 9. What is the Tn? A plus n minus 1d. Necessary you find out your last term. A is a 3 and difference is 3. So students, it is 3n. Again, last term of this one, 8, 11, 14, dash dash dash. So students, here also you can get Tn, A plus n minus 1d. A is 8, but what is the d? D is difference. 11 minus 8, which is 5. So 8 plus 5n minus 5, which is 5n plus 3. Now I go to our legally ascend students and ascend create your final answer. This is just some special series. Only these 4 formula utilizations I did. So your Sn is create 3 into 8, 6 into 11, 9 into 14, plus, that's the students, your last term is ready, 3n with 5n plus 3. Now according to last term, you can say sigma 3r and 5r plus 3. This 3r are taking from here and 5r plus 3 taking for that, and r become 1 to n. Now I go to multiplication and students, formula utilizations. So your value is going, Sn is a product, sigma r running 1 to n, 9, 5 3 is a 15r square plus 9r. 15r square and 3 is a 9r. 15 common take outside, sigma r square. 9 sigma r, 1 to n. Now apply sigma r square. This is formula ready, sigma r square. So your data is students, n plus 1 to n plus 1 by 6, and that is n plus 1 by 2. And very easily students, you also derive that type of solutions. It means here students, you can take the common, here 5 3s are and 3 2s are, again 5 3s are, 3 2s are, and now common take to universally your total value, and students, you easily derive that answer in the simplification of your Sn terms. Students, here by mistakes I written difference 11 minus 8, which is 5 not, it is 3. So sorry students, you can just correct 11 minus 8, 3. Here 3n minus 3. So what you get total? 3n plus 5. And that's your last term students here, 3n plus 5. Now here 3n plus 5 means here 3r plus 5. So your correction taking 3 3s are 9r square and 5 3s are 15r. So here 9 and here students 15. Now correct. So here 9 as it is, 6 same as, and students here 15 as it is, and n plus 1 by 2 sigma rs. Now I continue going. Here 3 3s are 3 2s are, and common taking 3 and n plus 1 by 2. 3 and n plus 1 by 2 common, remaining you have to 2n plus 1. Here n 3, 5 are remaining only. So your final data by 6 by 2. Now correct 2 to common and cancel. So 3n, n plus 1, 2 common, n plus 3 by 2. So finally you can done 3n, n plus 1, n plus 3 by 1, and that's the students, you are easily question number 6 happily done here. Now students, after 6 sums, 7 and 8 cancel according to your syllabus. So I go to now 9th one. 7 8 cancel, so I continue to 9th. Here last term given n square 2 raised to n, find out summations. So same pattern, last term of Sn is available to your questions n square 2 raised to n, and I want to sum. So very easy, Sn is sigma r running 1 to n. This is the last term available, so that I create r square, and here 2 raised to r. So students, sigma r square, sigma 2 raised to r, r running 1 to n. Now sigma r square as well as you know that n plus 1 to n plus 1 by 6, and here 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to n, and that's here students GP series. Yes, summation of GP terms you can create and easily converting into your answers. So here students, that's I explain about that. 2 raised to 1, 2 raised to 2, 2 raised to 3 in GP. A become to ratio 2 more than 1. So what's your Sn? A r raised to n minus 1 and r minus 1. So my Sn is create n plus 1 to n plus 1 by 6 plus, here students I apply my value, a is a 2, that is 2 raised to n minus 1 by r minus 1 means 2 minus 1. So finally your Sn done, and n plus 1 to n plus 1 by 6, here 2 with the 2 raised to n minus 1 by 1, and that is your students easily answer. Now continue question 10. Same as last term of Sn already available. So question is the 2n minus 1 whole square. So last term given, I want to summation. So what's your finally summation? Sigma r running 1 to n to r minus 1 whole square according to this last terms. Now I create the solutions. Sigma r running to 1 to n, same 4r square, 4r plus 1. Now sigma r square, 4 sigma r and sigma 1. Now putting value of r running 1 to n, r running 1 to n, and r running 1 to n. Now sigma r square students, you know, n plus 1 to n plus 1 by 6. Same sigma r also known, that one, second one, n plus 1 by 2, and here n by 1. Students, here 2 2s are cancel, that 2 2s are 2 3s are cancel. Now you take the common in first two terms. So here common available students, 2n n plus 1, 2n n plus 1, remaining are 2n plus 1 by 3 minus 1 here plus n as it is. 2n n plus 1 I common take outside, And further solution, students, it's very easy. 2n, n plus 1, that become 2n plus 1 minus 3 by 3 plus n as it is. So 2n n plus 1, 2n minus 2 by 3 plus n. Actually, this is also, students, you can operate further steps if you common taking 2. So 2n, n plus 1, n minus 1. Now this n plus 1 and n minus 1, it get n square minus 1. And 2 2s are 4n. 3 2s are 6 here by 3. So students, finally you create your here answer in the way of your last term of given, that 2r minus 1 in solution of Sn. So students, I continue here. By mistake I written here n, here 2. It is actually n coming. So here, students, your 3 into n, 3n. And data is covered 4n cube minus 4n plus 3n by 3. 4n cube minus n by 3. And n common if you, then 4n square minus 1. And that the two answers. One of the factors in 2n plus 1, 2n minus 1 by 3, and that the students here finally answer for these questions. Students, here our this exercise done and this topic also done. Now I going to supplementary part, exercise 9.4 related, 5 related, our parts of infinite series of the GP. So that also new topic and very interesting topic, students. Parts of our GP to infinite series. New topic. In GP series, infinite series, and that sum. So just like your AR square, AR cube, AR is to n minus 1, you know, it is a Tn. But I want to up to infinity. So in this case, special case, if r less than 1, then r is to n tends to 0, because terms going in the infinity, because n tends to infinity. Students, just consider, for example, I taking r is a half. So just you derive what is the answer for infinity. Half square, half cube, half raised to 4. Sure, if you infinity time are going, this data is convert to least to least, it means nearest to 0. That's why here r is to n I written 0. And our Sn is a1 minus r is to n by 1 minus r. This part is 0. So your data A 1 minus 0. So your Sn, if you given infinity, ratio r less than 1, then you can say this formula Sn, A by 1 minus r. And that I utilize in your further numerical in exercise. Continue next one. So students, other part is a cancel in your book. After that 9.4, students, miscellaneous example, exercise 9, all are cancel. I go to now our parts of 9.5 related supplementary chapter. Yes students, supplementary parts, I going that and easily explain about that parts of GP series. Yes, exercise 9.4. Find the sum of our GP 1, 1/3, 1 by 9 till up to infinity. So does infinity terms related we want to summation. So up to infinity we going easily. So students, here taking A1 ratio T2 by T1 which is less than 1, and into infinity. So here mention if n tends to infinity, then what is the Sn? A by 1 minus r. Already I derive here. For any r less than 1. So your Sn A become 1, r is a 1 minus 1/3. So 2/3, which is 3 by 2. That's your summations. 3 minus 1, 2/3. Continue. Question number 2, students. 6, 1.2, 2.4, dash. In your textbook printed here 1.5. It is a same. Here students also A is 6. R become 1.2 by 6. It means 12 by 6 into 10. So 6 2s are. It is 1 by 5. Definitely less than 1. And again write down if n tends to infinity for r less than 1. So what is Sn? A by 1 minus r. And only put it A. R put it 1 by 5. So 6 by 4 by 5. So 6 into 5 by 4. A 6. Then here create students your answer. Here 3 2s are, 2 2s are. 15 by 2, which is 7.5 only. Next, going ahead, third one is very interesting topic and very short topic, students. Yes, very short. Now third, 5, 20 by 7. Terms are 5, 20 by 7, 80 by 49, this. Up to infinity, yes. Given that, here also infinity. If you not given, then you write down itself. So what's your A? 5. Ratio 20 by 7 by 5. So 20 by 7, 1 by 5, 4s are. That also students less than 1. So again, if n tends to infinity for r less than 1, so what is Sn? A upon 1 minus r. And apply your A, 5. R become 4 by 7. So that is 3 by 7. So 5 into 7 by 3, which is 35 by 3. Yes. Continue. Going ahead, fourth sum. Fourth also students very easy and simple sum. If given terms is a minus 3 by 4, second 3 by 16, minus 3 by 64 to infinity terms. So same coming here, A minus 3 by 4, ratio R, T2 by T1, second term by first term. Again 3 by 16 into 4 by 3, but minus same, this cancel 1 by 4 minus, and what? It is less than 1. Same write down if n tends to infinity for r less than 1. So what's your Sn? A by 1 minus r. And put a A and r. A I have minus 3 by 4 and r become minus 1/4. It get 1 plus 1/4. So 5 by 4. So minus 3 by 4. Here 5 by 4. And easily you can get your answer, students, minus 3 by 5. 4 easily and happily cancel. Now continue. Question number 5th. That's also same pattern. And 5th is IMP. Prove that. Yes. Question number 5. Prove that 3 raised to half, 3 raised to 1/4, 3 raised to 1 by 8 up to infinity, which is 3. One more time check. 1/2, 1/4, 1 by 8 is 3. Students, here I just write down LHS. Half, 1/4, 1/8, infinity, and that's create your GP. So what's your GP in the A? 1/2 ratio 1/4 by 1/2, which is 1/2 less than 1. So if n tends to infinity for r less than 1, Sn is create A by 1 minus r. So your 3 raised to A by 1 minus r, 3 raised to A is 1, r is half. So your data is, students, 1 by half. Yes, A is half, students, by mistakes I written, and half cancel, it is RHS, and that's the very easily and quickly, students, done. Now 6th question coming, which is most IMP for exam related. Yes, I going ahead, continue. 6th one. 6 very interesting questions. There are three data, a combined given. Let x is a 1, a square up to infinity. Y become 1, b square infinity, where mod a less than 1, mod b less than 1. Then prove that, students, 1 ab a square b square up to infinity, xy below x plus y minus 1. Students, here actually 1, 2 and 3 proofing data given. I start first of all this. Here a, first term 1, ratio T2 by T1, which is less than 1, because modulus a given that less than 1. So what's your Sn? A by 1 minus r, if n tends to infinity for r less than 1. So Sn is summation x, a become 1 and r become a. So can I convert a separately? Yes, a become x minus 1 by x. Statement number 1. First solution is done. Now I going ahead to second one. Similarly, same as here, students, your a first term 1, ratio b by 1, which is less than 1, because b given less than 1. So Sn create a by 1 minus r if n tends to infinity for r less than 1. What is your Sn here? Y, 1 by b. Same is coming. Here also, students, I separate the b. Right side 1 by y, left side, so b is equal to y minus 1 by y. That's statement number 2. Now this both are attached here, so I third case start. In this case, LHS 1 ab a square b square to infinity. What's your a? 1, but ratio I write down the capital letter, students, because small letter available in the a. Ratio are ab by 1, which is less than 1, because modulus a less than 1, modulus b less than 1, so modulus ab, which is less than 1. So Sn is create a by 1 minus r if n tends to infinity. Then Sn is this. For here write down r, capital R, less than 1. Now what's your a, students? 1. Sn I create the answer 1 and r is ab. These a and b actually already I define and put down there. A you known, x minus 1 by x, b is known, y minus 1 by y, and here, students, simple you calculate doing the LCM and rearrangement. Only take the LCM and rearrangement. So 1 upon 1 minus, here multiply xy minus x minus y plus 1 upon xy. Now xy take upper sides upon xy minus xy plus x plus y minus 1, that and this cancel. Only you have to xy by x plus y minus 1, check, and that's your students RHS. Yes students, here our these questions with this exercise also students done, and this part also done. And now students, this chapter over here, because other numerical according to syllabus is cancelled. So students, now I meet you in the next chapter with the new chapter with new parts. Bye bye.